These are the notes of section 1.3, linear measure. The objective is I will be able to identify and measure line segments. So the first thing is we just have the definition of a length of a segment. It's just the measurement of a segment. Measurement is written with this lowercase m, and then we always write the segment. You'll see in the next section that we'll write measurement of an angle also, where we use the angle symbol. So remember, the segment mark is the little top that you put over it. It's the line. It represents the segment, and the M represents the measurement. So remember, if I wanted to name this segment, it would be segment DE, or if I wanted to find its measure, it would be the measure of segment DE, or the length of it. So we can measure the number line. There's a couple different ways to do this. If I want to find JN, it's pretty easy just to count. I go 1, 2, 3, 4, and that's going to be my answer. So the measure of JN is going to be 4. If I wanted to do a little bit more work, I just need to subtract. So I take the absolute value of J, which is -4, minus 0, and that's just 4. So I get it both ways. The same thing with GO, I can count it, and I would get 8. Or I could do the absolute value of -7 minus 1, and that would still get me 8. I'm going to change colors to kind of help you out with HG. It might be a little hard to see. This time I would just go this way, and it would still be 1. Measurements are never going to be negative, or it would just be the absolute value of -6 minus -7. That kind of looks like an equal sign. -6 minus -7. And this was just -7 minus 1. All right. So we can also add segments. We calculate segments using between points. So it might be better to say points that are in between. So you should be able to see that M is between points L and N. So if I want to find LM, that's this segment right here, I'm not going to add this, I'm actually going to subtract it. Because I see this whole thing is 4, and I need to take away this much. I need to take away 2.6. So LM is going to be 1.4. I get that from 4.0 minus 2.6. You'll also be given some problems like numbers 5 and 6. The best way to do problems like 5 and 6 is to actually write them out. It says find X and ST if T is between S and U. Let's draw a little picture. We have S and U, and T is between it. It says ST is 7X, SU is 45, so this whole thing is 45, and TU is 5X minus 3. So do you see how I would add this up? If I take the red segment plus the blue segment, I get the entire segment. So what I'm going to do is 7X plus 5X minus 3 equals 45. So you got to think back to Algebra 1 as to how to do this. You have to combine like terms. It's going to be 12X minus 3 equals 45. And then I would add 3 to both sides. And lastly, I would divide by 12. So I have X is equal to 4. So I found X. I also need to find ST. ST is easy. I know it's already, it's 7X. So I take this 4 and I plug it in for X. 7 times 4 is 28. Now for me, I kind of ran out of space for number 6. If you ran out of space, you might want to put it at the bottom here. I'm going to erase this. If you didn't get this down yet, make sure you pause the video and get everything. But for number 6, it says J is between H and K. So I'm going to draw it out. Again, H and K are my endpoints, and J is between it. So I just fill in these numbers. HJ is 2x plus 5. JK is 3x minus 7. And KH, so I go K to H, is 18. So just like the last one, I'm going to add again. The green segment, 2x plus 5, plus the red segment, 3x minus 7, is equal to the whole thing, 18. And again, I have to combine like terms. I'll put a circle around these two. So I'm going to get 5x. Actually, I'm going to erase that because it might be a little bit hard to see. So 5x minus 2 is equal to 18. And then I add 2. 5x is equal to 20. Divide by 5. X is equal to 4. So I solve for x. Now I need to find the length of each segment. So all I'm going to do is plug the x value in here and here. So HJ is going to be equal to 2 times 4 plus 5. That's 13. And JK is going to be equal to 3 times 4 minus 7, which is 5. And I want to make sure does 13 plus 5 equal 18. So if I would plug these in, 13 plus 5, it does equal 18. So that's good. That's a little check to make sure that we did it correctly. The last thing on this paper is congruent segments. We're just going to define this. So those are two segments having the same measure are congruent. Now we abbreviate congruent with that mark right there. It's an equal sign with a tilde above it. On the measures, we put little tick marks. The tick marks mean it's the same. So I would write segment AB is congruent to segment CD. We'll have some practice on this, and hopefully it'll all make sense. These are the basic building blocks that you're going to need for geometry.